Okay, I'll switch to English. I actually got a bit betrayed by Tomek, who was also supposed to talk in English today, but I'm unfortunately the only one, but I really hope that it won't be a problem. And today I want to talk you through my recent vulnerability report that I got rewarded by Google on how the basic viewer role lets you copy the hard drive contents, including the encrypted ones. Just to get the feeling of the audience, is any one of you actually using GCP on a daily basis? Cool. What about AWS? And Azure? Oh, wow. Some multi-cloud people here. Cool. Good to know. Okay. So let me introduce myself a bit. I'm Alex. I am actually not a security researcher. I'm an engineering manager by day, and security research, especially the cloud security research, is just my hobby. I am currently working as an engineering manager at Nala, and previously I worked in the Orca security, and I led the R&D group as a senior engineering manager. In total, I have around almost 10 years already of experience in tech, and outside of tech, you'll find me in the boxing gym probably, or at home playing video games and reading books. That's a bit about myself. Yeah, let's move straight in. Today, I will show you how a basic viewer role lets me copy an encrypted production hard drive into a project that I own from the victim project, from your project, without ever accessing any encryption keys and without having any permissions on the encryption itself. This was a security vulnerability that I found in October. I reported it to Google at November last year. It was acknowledged by Google. The patch was even published. But after the patch was published, I found a snapshot bypass, and it's actually currently live. And today I'll show you and explain you how this was possible in the initial report, and how the bypass works. Yep, it's actually the first time I'm showing the bypass ever, so it was not yet disclosed, though Google is working on fixing it. Yep, so now you'll have the exclusive content a bit. Okay, so let's move to setting up our stage. What is the threat in question? The attacker doesn't need any exotic permissions. It's just a principal, just a user or service account inside the victim project. This principal should carry the compute.disks.useReadOnly permission. And this permission is actually included in the viewer role at the moment. It can be either a service account, it can be either a CI/CD leaked service account or agent service account. The second one is much more popular now in the VibeOps era that Gregor has also talked about a bit. And this service account should only hold the viewer role and leak its key somewhere. Those are the most common shapes that I'm seeing, and the real incident that I saw regarding the leaks of service account keys. The important part here is it's just the only permission, the compute disks use read only, that is exposed in the your project, the victim project, for this attack scenario. Let's talk a bit about this role, this permission. The attacker, basically, wait a sec, yeah. The name of this permission does sound not that harmful, right? So this is a single permission that you must have to be able to use the disk to create a snapshot of it or to clone this disk. And this permission is bundled currently in more than 30 predefined roles by Google, including the legacy basic roles. And I'm talking the viewer, editor, and owner. The viewer, the first one, you can imagine it's the most exposed one, because who we usually grant viewer to? It's all of the auditors that request the access to audit our environment. It's all of the support engineers, in case you're working with third-party support in Google, for example, the Cloud Zone or any different support engineers. It's third-party services, it's AI agents. And during my time working at Orca, I personally found out 4 security companies that request the viewer role as part of their onboarding. It means that when you actually onboard with a security company that should actually protect your environment, you're already granting them the viewer role. And this is just to imagine the blast radius of the issue. If you were to remember only one thing from my talk today, I'll ask you to remember this one. Treat compute.disks.useReadOnly as an equivalent to can't download the hard drive. This is not an exaggeration, it's actually true, and let me show you. Before we go to the demo, let me quickly go through the encryption model at GCP, because this will actually be used in our future slides, and I want you to understand this. The first one is Google Managed Encryption Key. It's the default one. Once you create the disk, Google assigns it by default, holds the key, manages the rotation of the key, and anyone with the IAM permission to the resource that you're trying to access will automatically be able to decrypt it. And if you are looking for some more security, the selection that you'll go with is a customer managed encryption key. You create the key through the Cloud KMS service. You encrypt the disk using this key. You rotate this key, you revoke this key, and you have full access across the resources that use this key. The promise of a doc, of the Google documentation actually, is that only principals granted the KMX access to decrypt using this key will actually be able to read the contents of a disk, for example, or a storage bucket. And this is something that we will actually challenge today. Just a sec. So, time for a first demo. We will start with the most simple case, which is a Google Managed Encryption. This is a baseline and the most common setup for any GCP disk, unless you set something up. So when you create a disk through the portal, through the CLI, with any source of it, you can actually, the disk by default will be created as Google managed. And let's walk a bit through our setup of the attack. We have 2 projects. The victim one, which I will be calling the source project. This project is actually containing a couple of disks, including the Google Managed Encrypted disk. We have an attacker project. This project sits outside of the source project organization, so it's basically a separate project that attacker has full access to. And we have a principal. In our case, it's a service account that has just the role viewer. You can see it on the right. Just the role viewer on the source project. There is no more cross-project IAM, there is no KMS access, just the plain viewer role. And let me just start it all over again, sorry. Let's have a look at the recording. Here I'm actually doing the basic things that any attacker will do. The first one, I'm authenticating with a service account that I will be using and logging into the source project. Yeah, it takes me a while to type, but bear with me. Now I will be just doing the plain things that attackers usually do, research the environment they're in. So in this case, I'm just doing the listing of the disks in the environment. Yeah, and here we can see a couple of disks, right? The cross-account lake example, customer managed encrypted data disks, and source VM. Let's try to describe the first one. Cool. We can see that it's a plain PD balanced disk without any encryption. And let's see on the second one, which is a customer-managed encrypted disk. Here you can see the disk encryption key. It's on the top, and it mentions the KMS key name that is used to encrypt this disk. Let's switch to the attacker project, and let's try to steal this disk. Let's try to steal the Google managed encrypted disk first, the one with the default encryption. Here how the command looks. It's basically creating a disk clone with the source of a disk that is located in the source project. You can see that it's using the impersonated service account, the one that has the viewer role. And we see that it succeeded. The disk is currently on the attacker environment. Here, let me stop for a bit. No, let's move on. Here we are, just to prove that it actually works, I'm currently attaching the disk to the attacker VM, the one that is located in the attacker project. And let's now try to SSH to the VM, and I'll walk you through some of the commands that I'm doing here. So I'm basically mounting the disk after it was attached. I'm mounting the disk to the MNT stalling directory, and I'm basically doing the cut on the secrets.txt file that is located in this disk. And hooray, we have the secret data from production in the attacker project that is completely separate from the source project. Great, this was the easy case, right? But what about customer-managed encrypted disks? Those are the disks that you usually actually have to prevent these situations, right? But maybe it doesn't really work like this, right? And this brings us to my original report to Google. The assumption was that we already went through, is that even if attackers can access the disk metadata through the viewer role, they cannot read the data in the disk because they don't have the permission to decrypt, right? And that was actually the whole premise of the customer-managed encryption key. But unfortunately, it was not the case, and it succeeded. And when I did exactly the same operation that I showed you with the Google managed encryption key on the customer-managed encryption key disks, those actually succeeded. And unfortunately, I cannot show you because it was patched in the January 2026 this year. But let's have a look on how it was patched, and let's do a quick demo on this. Let me walk it through. So here you can see me as an attacker attempting to do the customer-managed encrypted key copy using the impersonated service account, the same one as we were using before, just with the plain viewer role. And you can see that currently it will show you an error that this disk is protected with a customer-supplied encryption key, and we're not providing this one. And this is the actual direct fix that Google introduced. And now you might think that, yeah, deal closed, we are okay, but actually not really. One note before we move to the snapshot bypass and talk a bit more about this. The viewer role that you are assigned as an attacker in this scenario cannot create new disk snapshots anymore. I'm saying anymore because it was possible a couple years ago. Google patched it. They still have a permission, the old permission that was used previously to create the snapshots. It's compute.disks create snapshot or something like that. I can show you a bit later. But yeah, currently this permission is no longer used, and they actually created a new permission to create a snapshot, and it's not included in the viewer role. So we cannot create snapshots just with the current role that we have, though, and this is the important though, if the victim has already the scheduled backups enabled, and this is actually something that GCP recommends, and if you were to create the disk through the GCP portal, it automatically creates the disk with the scheduled backups, and also all of the production disks that I faced do have the scheduled backups enabled just because it's a production system. Or if the disk already has a manual snapshot of this custom managed encrypted disk, the snapshot already exists there and the snapshot is already lying as a project. And the attacker just needs a single intermediate step to be able to bypass the fix that Google did. And this step is actually finding an existing snapshot, and that's it. So basically, including the roles that are included in the viewer role are already allowing you to find the existing snapshots, to list the existing snapshots, to list the disks, and also to list the snapshots that are created automatically. So this is basically same attack, but using a bit different API. And let me show it to you. This is actually something that is live currently in GCP. So that would be good if you won't use it. But yeah, just a note. So let's watch the recording together. Wait, no, that's not it. Just a sec. The first thing that we are doing is, again, logging into the source project, the big team project. And again, looking through our environment. We have a couple of disks here. And the one that is of our interest is the example custom managed encrypted data disk. Let's describe it, and we see that it's indeed encrypted with the KMS key. And let's list the snapshots. Yep, we see that this disk was indeed snapshotted, and the snapshot is custom managed encrypted snapshot. Let's describe it, let's see what it has. And you can see that this snapshot is also encrypted with the customer managed encrypted key. So the encryption from disk is actually duplicating to the encryption of a snapshot. And that's something that Google does well, in my opinion. But let's switch to the attacker project and try to do the same as we did. Let me stop for a moment. Let's try to do the same as we did, but using the source snapshot and instead of source disk. So we're creating a disk copy based on a source snapshot. That is actually the one that we just saw right now. We are using the impersonate service account, the same one as we used before with the viewer role, and you can see that we are actually succeeding. So we can still clone the disk, even if it's a customer managed encrypted disk, to the attacker project, bypassing the encryption. And let me show the bypassing to the encryption part to you. So here we are trying to describe the snapshot. Oh, sorry. Yeah, I'll do a couple of iterations of this, no worries. I'm like a bit bad with typing sometimes. Cool. So we have the snapshot, and you see that it doesn't mention any encryption. It means that encryption was stripped from the snapshot. And here we are attaching the disk to the VM. We are doing the same, the SSH to the VM, mounting the disk to the stolen CMEK directory, cutting the same secrets, txt, and we have the unencrypted secret data from production accessed in the attacker's project that should have been encrypted by the key in the source project. So let's talk a bit about why it was possible. Wait. I'm moving a bit to the much lower levels that I was before, and we will discuss the service agent entity. So in Google, as some of you probably know, there is a concept of service agents. It's the agents that some of the services, for example, the compute, storage, etc., use underneath to do some operations. And the compute engine service agent is exactly the one that is used in this case. Me, as an attacker, holding the compute.disks.useReadOnly permission, trying to insert a disk in my attacker project using the source disk from the target project. In this scenario, it actually is not checking if I have permission to a key that encrypts this disk, just simply because I'm not passing the key. in the CLI command. And what I'm doing, what the Compute Engine service agent doing on my behalf, it tries to read the source disk, tries to decrypt it with customer managed encrypted key, and writes the clone to the destination disk project. So basically, Compute Engine service agent does all the heavy lifting of decrypting on my behalf, even though I don't have permission to decrypt. And this is how it was explained to me by Google, and this is how it still works, but with a specific detail. So basically, just the thing that I explained at the moment. This service agent is used. I don't have any permission to decrypt, and just have the user read-only on disk. And this is actually something that we in cybersecurity have a name for, and it's called confused equity. It's a privileged component, in this case, service agent, acting on a less privileged caller request. So basically, when something that is more privileged than us, trying to do things that we can't. And this is an example of this issue. So just a very important note here. The clone is actually automatically re-encrypted by Google using the Google managed encrypted key. So basically, since we are not passing the KMS key to create a disk with, Google is automatically deciding by us to encrypt it with Google managed encryption key. And in terms of Google, it means that we are decrypting the previous encryption and re-encrypting the disk with a Google managed encryption key. And this is the whole thing that service agent does. So basically, the disk is not like stored in the plain text on your environment, but rather is re-encrypted with the default encryption that is available to decrypt in the attacker's project. And there is no more custom managed encryption key that's used to guide this access. So okay, what we can do with this? The strongest one and the first one, it's a new service that Google introduced quite recently, the VPC service controls. And it's actually a managed service that allows you to do the blocks on some API calls and some services calls outside of the perimeter. That's quite a setup to build actually, just because you need to know all of the things you want to allow and all of the things you want to restrict. That's why the easiest, in my opinion, way is org policy constraint, which disables the cross-project service account usage. It means that if one service account tries to call the resources from another from another project, it will be disabled by default. This is org policy that I think all of the organizations in GCP should have now. And I even recall that GCP starts to enable it by default for some organizations, at least for the new created. The obvious one, basic roles is a not good thing anymore. Those are very, very not least privilege. I'm sorry. The examples, like the viewer role, it's something that when I see it in my customers' projects, it's something that I'm usually flag, and this is something that is very, very exposing to a lot of different attacks, including this one. Try create the custom roles where possible with specific permissions that are only metadata reading permissions. And by this I mean for this specific case, try to scope the permissions for this get and disk list and can exclude the disk user, compute disk user read only. Sorry. This is like something that we usually talk about, but no one does it. But anyway, worth mentioning it here. And audit snapshot schedules. This is something that, in my opinion, quite important, both for cost implications and also for this specific issue. Be sure to understand and know who can access the snapshot and the snapshot schedules. This is something that is very important nowadays. So yeah, this is another recommendation that I can actually flag. And yeah, let's move to the takeaways a bit. Indeed, my hook from the the beginning that the compute.readOnly is equivalent to candle now the hard drive. This is the most important thing that I want you to take home from this presentation. There is actually another one, which is also a big one. The service agents in GCP is something that is usually leading to confused deputy, and the fact that not everyone actually knows how it's working is allowing for a lot of attacks to be slipped in. And it's a common scenario where the service agents in GCP are used for the such attacks and for the compute deputy scenarios. So make sure to audit the service. The service agents, and the activity of those agents must be monitored as well. And this is something that we usually not putting too much attention to. So yeah, that's actually it from my side. I'm really happy to take questions. I know that it was like quite too technical, but yeah, in case you have any questions, please feel free.
Have you found similar vulnerabilities in Azure infrastructure?
There is not a similar one, but there is actually a very fun one with Azure disk encryption. Do you know the AD disks? Mm-hmm. Yeah. So basically, there is a fun one. It's basically a write-up that I'm currently working on, but there is a couple of ways to do this as well in Azure, including the Azure disk encryption that should have been the most secure way, right? But yeah, not really. In AWS, basically, there is no such vulnerabilities that I know of at the moment. Though I didn't spend a lot of time researching it, but looks like all the such holes in AWS are actually quite fine. Any more questions? Okay, cool. So yeah, please don't use the last one. It's still open. Google still haven't fixed it. So yeah, I'll appreciate if you won't.